let me introduce the abelian group Z sub n under addition and multiplication. I'll look at Derek Robinson's abstract algebra book. Two integers, a and b, are said to be congruent module m, like this, a congruent to b mod m, if m divides a minus b. Congruence module m is an equivalence relation on Z modulo m. The classes are congruent mod m. There's exactly m congruence classes, namely bracket 0, bracket 1 through bracket m minus 1. The addition of those equivalence classes and the multiplication of those classes are defined by, if you add two equivalence classes, you add the numbers in them and take the equivalence class for that. So a mod m plus b mod m is a plus b reduced mod m. So same thing for multiplication. So we do need to ensure that the sum and product depend only on the congruence classes, not on the chosen representatives. And he does the work in the book here. We know that these are abelian under addition and multiplication. They are associative. We have an additive inverse. We have, let's see, additive inverses and a distributive property. So actually, let me go over this a little bit more. All right, so we said congruent mod m if m divides a minus b. All right, so it's an equivalence relation on the integers. So as an example, z sub 6 under addition, not only does it form a group, as can be verified, but it has two subgroups, one generated by 2. Just think two, I'll do one of the group tables for these. So 2 and 3 are the two subgroups, the ones generated by those. And under that is the identity group. But let's actually look at one of the subgroups of Z sub 6. All right, so Z6 plus is the name of our group. And let's look at the group generated by, how about the number 3? So you got the element 3. If you do 3 plus 3, you get 6. And 6 is congruent to 0 mod 6. Because 6 minus 0 is divisible by 6. The, here. Where was it? If m divides the difference. So if you're looking at 6 and 0 mod 6, then you look at 6 minus 0, and 6 divides 6 minus 0. 6 divides 6 evenly. So that's congruent mod m. Now, so 3 plus 3 is 0. And we'll use parentheses around 0 for the additive identity. and parentheses around 1 for the multiplicative identity. So we know that 0, the identity, is in the group. 3 plus 0 is 3. 3 plus 3 is 6, which is congruent to 0. 0 plus 0 is 0. So the group has two elements in it, the identity and the number 3 in Z sub 6. Let's look at the one generated by the number 2. So the group generated by the equivalence class of 3 is literally just 0 and the equivalence class for 3. All right, let's make another group table here. All right, so so we did 3. Let's look at the one generated by 2. So you got 2. 2 plus 2 is 4. So 4 is in the group. Okay. 4 plus 2 again is 6. Oh, and that gives us 0. So we get the identity. Zero's the oh, I need 0 here too. Sorry, people. So you have 0 plus 0 is 0, of course. 0 plus 2 is 2. 0 plus 4 is 4. 2 plus 0 is 2. 2 plus 2 is 4. 2 plus 4 is 6. 6 is congruent to 0 mod 6. Four plus 0 is 4. 4 plus 2 is 6. 6 is congruent to 0 mod 6. 4 plus 4 is 8. 8 is congruent to 2 mod 6 because 8 minus 2 is divisible by 6. So this is 2. So let's see, we got in the group generated by 2, we have 0, 2, and 4. And that has 3 elements. So the two subgroups, the subgroup generated by 3 has 2 elements. The subgroup generated by 2 has 3 elements in Z sub 6. And that covers all the elements. If you look at the number 1 generates the whole group. 1 plus 1 is 2, plus 1, 3. So that 1 generates Z sub 6. That's the whole thing. The number 2 generated these 3 elements. The number 3 generated these 2 elements. The number 4 plus 4 is 8, which is congruent to 2 mod 6. So 4 generates this group, the one represented by 2. The number 5, 5 plus 5 is 10. let's look and see. Maybe I made a mistake somewhere. Let's see what the number 5 generates in Z sub 6. So the equivalence class for the number 5, if we add 5 to itself, that's 10. 10 is congruent to what mod 6? It has to be divisible by 6. So 10 is congruent to 4 mod 6. So we have 5. We have 5. And we got the number 4. Now if we add 5 again to the number 4, that's 9. And 9 is congruent to 3 mod 6. Add 5 to 3, add 5 to 3 and that's 8. That's congruent to 2 mod 6. Add 5 to 2, that's 7. That's congruent to 1 mod 6. And lo and behold, you're generating the whole group. And add 5 to 1, that's 6. That's congruent to 0 mod 6. So 5 generates the whole group again. So that shows manually that Z6, the only subgroups of Z6 under addition are the group generated by 2 and the group generated by 3. Okay, and that's a little bit about Z sub 6. Thank you.